So up next we have a topic that should be very interesting for the non-US people. We're making software understand our non-US accents. Up presenting is Douglas. On to you, Douglas.
Thank you. Yeah, so I'm talking about how to make open source speech recognition work without an American accent, or even with a non-standard US accent. This is a diagram of how speech recognition works in like an abstraction until it's a lie almost. You get a whole lot of data and you squeeze it through training software and it makes a model. And then they have what they call a decoder that takes your unknown speech and turns it into text. Now, calling it a decoder kind of implies that speech is encoded text, which isn't quite the case. And so what you really need is a theory of mind, not just a theory of how speech can be turned into text. But this is in more detail. You have the model actually has three parts. And there's an acoustic model that takes the sound and finds phones or phonemes in it. And then there's a language model that maps phonemes to words. And then there's a pronunciation model, which it's a glue between the two bits. So it maps a word to a string of phonemes. And the language model really is finding probable sequences of words. And the language model and the pronunciation model together, they make up a probable sequence of phonemes, and then the acoustic model sort of tries to find that. And that's why I'm talking about the top part. And now the acoustic model is made from speech examples that have an exact transcription for each example, and then there's a whole lot of text that makes a language model, where the pronunciation model, it just comes from somewhere. It's a model of English spelling, which you can't really get from anywhere except the people before you. And so here are some of this open source speech recognition systems, the biggest ones that I could find. Julius, it's a Japanese system, so they don't actually have an English model, even a US English model. And they've got a really strange license, as if they took a BSD license and put it on a wiki and then translated it to Japanese and back again. But I think it's a free license. I can't really tell. But the models they use are based on models from HTK, which stands for Hidden Markov Model Toolkit, which has a non-commercial license, so you can use it for your research, but you can't make any money from it. And then, so the models that it makes, though, are free. It's like a PNG that you make with Photoshop. It's not restricted in itself, but it's grayed out because it doesn't really count. And then Cowdy is like a reaction to HTK. It has a more open development process, and they used to open a license, and they because they're a new project, they said we're not going to have any crufty old algorithms. We're going to only have the best stuff. And they don't even call themselves a toolkit. That's how much they hate HTK. And then there's the Sphinx, CMU, Carnegie Mellon University Sphinx family. And there's a whole lot of those, but I'll talk about them soon. And then there's smaller projects. These ones, they had EU funding for a while, and then it ran out, and the professors went on to do something else. And then there's a whole lot of people who have tried a new system, put something on SourceForge, and then left it. And so there's lots of abandoned things. The Sphinx family, the first one was a closed source model system. And then the second one, they opened it up. And then, because it's developed in a university, it's all done in PhD-sized chunks. And somebody comes along with an idea, and they do their lump, and they put it on the top. And then they go away and get a good job, and then someone else comes along and puts another bit on. So it kind of grows like a coral reef, and it's not integrated. It's just a mess. Nobody gets a PhD for maintaining stuff. So they keep rewriting it, and they rewrote it, Sphinx 2, then 3 in C, and then somebody rewrote it in Java. And then they found that Sphinx 2 actually was quite good and fast, and it could do some useful things in almost real time on smallish devices. So they called that Pocket Sphinx and sort of kept on going on it. So Sphinx 3 and 4 and Pocket Sphinx are all, in theory, current. Don't think many people are using 3 anymore, but there are people working on the 4 and the Pocket Sphinx. And that Pocket Sphinx is the one that I'm most interested in. But it's really arbitrary, the choice, because the things that you need to make a model, it doesn't matter what software it is, you actually just need the data. So it's all the same. Now, to use Pocket, if you're American, this is what you'd do. You'd just install the modules. There's packages for Arch and Mandriva, or whatever you call it these days, and Fedora, and then you might write a little script like this. Now that changing the directory thing, that's just to make the slide not go like that, because to keep the paths short. So those blue lines, they define the 3 models. The dictionary, the pronunciation model in Sphinx is called a dictionary, because that's what it is. And then you start up a decoder with those, and the Seek44, that's how you parse the wave header. And then you get the hypothesis, the best hypothesis, which is of whatever that speech is. And here is a lightning talk of somebody doing what I just said. The guy who wrote Pocket Sphinx, or rescued it from being Sphinx 2, and everything goes wrong for him, and he finishes in 4 minutes. So it kind of shows how simple it is once you're using it. But anyway, I'm not going to talk about software. I'm talking about speech recognition, and I want to talk a bit about some linguistic concepts, which kind of show why the American models don't work for us. So a phone is like a particular kind of sound. Like if you hold your tongue in a certain way, or move your tongue in a certain way, and breathe, you'll make that phone. This picture here with the square brackets around the AE thing, that AE thing is an ash. And now when linguists use square brackets for talking about phones, that's an exact sound, and that's about the sound that the vowel in trap, when you say trap, not when I do, I'm a New Zealander, I used a different vowel, but when you say trap, most of you probably, that is that sound. Now a phoneme is, when I say trap, I'm using the phoneme, the ash phoneme, but that's like a way of saying, well, we know what he's saying. You can understand me. So we'll say that it's the same sound. That's the New Zealand ash phoneme is not the ash phone, and different, more than one phone can map to a phoneme. Like there's 3 different kinds of P that we use, and dozens of kinds of ways people say T, but they all become one phoneme. And a lexical set is a collection of words that are pronounced with the same vowel, but there's also, like if you're an American, you use the same vowel in the word bath, but the bath is a different lexical set. So these are some things that are relevant to what I'm going to talk about soon. Now, in this vowel chart is demonstrating where the most closed part of your mouth is when you're making the vowel. So this symbol here is the sound that almost everyone makes when they're saying book. So here are some English vowels. It's not all of them, but and there's a couple more dimensions than just a vowel chart. Americans use R-coloured vowels, which we don't, and some vowels are pronounced with rounded lips. Anyway, so the vowel in plum. Different people use different parts of their mouth to make the same vowel, right? So I think that might be clear enough. Now, here are where Americans use American vowels, say, that trap and bath. They use the same part of their mouth for that. And then lot and palm are the same, so that makes father and bother rhyme in the general American accent. And thought and cloth are the same vowel. And it's actually, this is a part of America that actually speaks the standard dialect. It's not even a whole state. It's little bits of a few of them. But because on the East Coast, you know, the older parts, everybody got their own dialect, like you hear about Boston and Baltimore and all those places have a dialect. And then they went west and sort of all banged together and grew corn and stuff. And then when they went out further west, they sort of spread out, and California has a California accent, which is very similar to general American, but it's not quite the same. And the South, well, we know about the South. So now, this is a posh British accent. I had Tim Berners-Lee there this morning, but he doesn't speak RP, received pronunciation. So after watching him this morning, so I changed it to Prince William. So I'll just flick back and forth between those. So the Americans, they join Bath and Trap together, and in the UK, Bath jumps across to join with Palm. And and if you look at thought and cloth, cloth and lot are the same vowel to us, but they're not to Americans. Now, this is getting to why you can't just use an American model. Yeah, and so in Australia, now there's two things that happen. In this Bath lexical set, actually some of the words have jumped out of that into the Trap lexical set, like dance and glance, except in Adelaide where they've stayed with Bath. And then there's all these ones that are rushing up into the front corner, like this bottom bit down here has emptied out, if you compare it to the back to the RP. All those vowels are rushing from the back of your mouth up towards the front and the top. And so the kit vowel, you know, raced up into the corner. And then the fleece vowel became a diphthong. So to avoid kit, because if those two merged, no one would understand you. And then, but you know, what else could kit do with all that going on? Well, this is what happened in New Zealand. The same thing was going on. All the vowels were, because New Zealand and Australian accents are actually, to most of the world, they're almost indistinguishable. But I mean, to us, you know, we can't even understand you. But the interesting thing that happened in like I was talking about the trap, my trap isn't using the ash phoneme, phone, because in New Zealand it's gone up, and then the dress vowel is just kind of racing away further and further up. Now this is actually happening. My dress probably isn't that high, but in younger New Zealanders it's higher. These things are happening quite fast, and everybody's English is the new generations make up new things, and you can actually hear, if you listen to older people and younger people, you can hear the accent changing. But anyway, so the kit went into the middle and merged with the comma vowel, which is the vowel, the first syllable in about, the last syllable in comma, and anyway. So this is like just some of the consequences. Yeah, I talked about father and father. And panda and panda. Now, Americans pronounce those two differently because they have this rhotic accent where they pronounce the R's, basically. And altogether they have 40 phonemes, but Sphinx manages to get by with 39 because they decided that the schwa, which is the kit, I mean, not just for me, but the comma vowel, they decided that was the same as the unstressed strut, because it's the same as the unstressed everything, pretty much. So they could do without it, anyway. And in Australia, yeah, I mentioned fleece, and there and square, in most places the monophthongs, and the diphthongs, and now the other monophthongs. So there's 44 phonemes. And now, there's 44 phonemes in Australian English and 39 in Sphinx's American model, and then in New Zealand English. Now, this is a funny thing, bear and bear. I can't hear any difference. That's the near and the square diphthongs, but to New Zealanders, or and my generation was one of the sort of the first generation to do this, to just abandon the distinction. Like my teachers would say, it's not bear, it's bear. And it's, you know, because they'd lost the, pretty much lost the distinction, but they thought they could hear it. Well, they could hear it in us, but because no one was making this, these things, once you stop saying it, you stop hearing it, and I just can't hear. But it doesn't matter. I mean, we don't have bears, and you're not even fake ones like koalas. It doesn't matter. But whereas the kit and the fleece vowel, if they merged, that would sort of confuse things. So, yeah, we did have 44 phonemes, and we're sort of dropping a couple of them by merging the kit and the comma and the bears. So that's a summary of what I just said. That there's two big collections of vowels, and they don't overlap, or they overlap a bit, but not enough. So now I'm talking about the acoustic model, which it's actually a bad illustration of a hidden Markov model. But a hidden Markov model means Markov donated his name to maths to mean something that depends on the next state depends on your current state. So as you're going through time, where you've just been, the next phoneme depends on what the current phoneme is and what the previous one is. And then hidden means that the evidence that you've got for it isn't direct, so you don't actually know. From hearing the sound, you don't know directly what the phonemes are. And that's what they use. Almost everyone uses this to model speech. And even there's a whole lot of new algorithms, which if I've got time at the end I might talk about. But they kind of use a hidden Markov model anyway. So this is, if someone says Canberra, the sound goes in, it kind of goes through this thing. And now, like, the combination of N followed by B is a rare thing in English. You don't do that much. So it might decide that that's two words, or that might decide that you're actually saying an M, or might decide that you're saying a D or something like that, because that's unlikely, and so the probabilities of it recognising that you're saying that are lowish. Anyway, and Canberra's not very common to be talking about unless you're here. And so there's two ways you can make a new acoustic model. You can adapt an existing one, which for that phoneme stuff before, the count of phonemes, that kind of restricts what you can do. So you could adapt an Australian one to an American one more easily than another way around, because the Australian one has more phonemes to play with, and it's easier to learn a merger than you can't make it split something. So you can create a new one completely, uses more data, and it's more fiddly. So the data you have is you have a big long text file with small sentences, and then in parenthesis at the end of this sentence you have an identifier, which is like a file name, and then so in the file you have the audio, and it just goes through that whole list, and it reads the line and it listens to the thing. It tries to line them up, and if it can align them up, then it kind of makes associations between the what was spoken and what was written. And as far as I know, that's the same process. Even whatever algorithm you're using, whatever software you're using, you need something like this, the same thing to do the training. So where do you get a hold of? I don't know if I mentioned the number. You need 150 hours of speech like that, of small snippets of speech. Like 10 seconds is probably about ideal. 10-second snippets of speech with an exact transcription, including ums and ahs or any missteps. So linguists have a lot of speech that they use for research. Like here, there'll be a linguistic department, and they've got a corpus of speech. Parliament has a whole lot. Voxforge, actually I've got slides about all these. So in New Zealand, there are two big speech corpora. They've both got lots of hours, but now the Wellington one was made in the 90s, and so when they were transcribing it, they were using typewriters and stuff like that, and so they don't have exact timing. Like they're listening to a conversation, and every minute they put in a minute marker. So when you're trying to split up the audio and the speech to the audio and the transcript to get into these 10-second snippets, you can't do it without recognizing speech, and then you're actually in a bit of a vicious cycle. But the Canterbury one, they wrote software and transcribed it using the software, and so they've got exact timing, or pretty good. And they've got a program, and they've GPL'd their software, and they're interested in making a speech model for New Zealand English, and they tried it and it didn't work. And the reason it didn't work is the thing that linguists like in their research corpora is natural conversation with people all talking at once and pretending they're not being recorded, so that then they get a snapshot of what people are really saying, and that's where then they can write a paper about the stress vowel is rising in New Zealand English. Or, that's where all those the phonemic knowledge comes from, and it's all about speech patterns and stuff. So the things that speech recognition engines need is they really need the equivalent of infant-directed speech. So they need baby talk so that they can get a start. You can't just train them up with everyone all talking at once, so they won't learn. The same as children won't learn like that. So it turns out that these research corpora are not necessarily very good for making a speech model. And there is an Australian national corpus. We've got 2 of them. You've got millions. I mean, you go to this website and there's a list like that of all the universities, or maybe not all of them, have their own corpus of Australian speech. And some of it's on the web, whereas the New Zealand ones aren't on the web. You can't even listen to it or even look at it unless you go to the place and they trust you, because it's people talking about their real lives. It's private conversations. Now, another source is Hansard, which I think you call it Hansard here, do you? Yep. Yeah. Now, in New Zealand, there's a thing called the CERA. This is an example. The Canterbury Earthquake Recovery Authority. In Parliament, an MP will say, ask a question about CERA, and the Hansard will expand it helpfully for anybody who wants to know what they're talking about in 100 years. But for the purposes of speech recognition training, it's a disaster. And then sometimes and if the MP says 1200, like they do, then the Hansard will contract it down to the 4 digits, and then when the speech engine is trying to line that up, it might expand it the wrong way, you see. So VoxForge is a project to make open source speech models, and they collect little bits of speech. There's a Java applet. I must be probably the only person this year who installed the Java plugin, but I did. And it gives you a sentence. It gives you 10 sentences at a time, which adds up to a bit less than a minute of speech. And you click on record and you say what you read it off. And then if you don't like it, you record it again. And so you're giving it, you're submitting to VoxForge exactly what is needed for speech training. And this is all from, I don't recognize it, but Dickens or something. And so it builds up a speech corpus of GPL speech, which is a little bit of a stretch to call it source code, but they do that. And then, so if you search for it in Google, because they don't have a direct search, after 6 years, there's about 45 minutes of New Zealand speech, and about 50 minutes of Australian speech. But this was the case, but then I saw this, so I fixed it, and then I did 10 more samples, and now New Zealand's ahead. And then if you look at, so like the same kind of demographics as this conference. The people who read VoxForge are sort of young men, really, people who care about open source things and are techie enough to sort of do that stuff. So there's hardly any female speech, there's hardly any old people speech. Senior, I think is the word they use. And there's hardly any young people speech. It's all young adults, or middle-aged like me. But yeah. So if you use that, you would. Sorry, I'm just back on the other one. If you use that, you would make a good model of kind of geek speak, but not a good model of general Australian or New Zealand speech. If you had 150 hours and not less than 1 hour. So other sources are on the Radio New Zealand. They read the news and then they put almost exactly the same news on the website, so you can't quite use it. They must have a script because the newsreaders don't just make it up. That's what the reporters are for. And then on the teletext subtitles are completely different than the actual what is said. It's a paraphrase of the conversation, but it has been suggested to me and that you can get the actual script of something like Shortland Street or Neighbours or long-running soap opera, where they just get their lines, they read it, and it's probably a good recording and probably less background noise than a real conversation. And then there's audiobooks where people they read Jane Eyre from beginning to the end, but you can only use the first 10 seconds because the rest of it you lose the timing. And then, but the trouble is, if you use any of those, you can't use it with VoxForge because VoxForge is GPL and the other ones aren't, and they aren't freer. But you could argue that actually the copyright doesn't really transfer through to the model if you used whatever your speech source. You're squeezing less out of it than if you, say, indexed a web page or something. You could argue that you shouldn't really care, and that your model is a whole new work. But you wouldn't want to do that with VoxForge. You'd only want to do that with the free ones. I mean, the non-free ones. So I thought I would have this sorted out. You see, I started on this 8 months ago, and I found that it's actually really hard. And there's no real good. How much time do I have? Heaps. All right. No good sources of speech. So I've been wondering about making a website that does the VoxForge capture thing. It gives you a line and you speak, and forwards it to VoxForge. So that's also in GPL and also in a more free license, so that then the more can also, it can, rather than waiting for VoxForge to get 150 hours, you can actually combine it with other things in the meantime. And then when VoxForge is there, then they can use it also. And then another way would be to just talk to the TV people, which I haven't actually done yet, about the scripts. Because if there are scripts which are accurate along with the TV recordings, and they probably have the time code and on it and all that stuff, that would be good. But and I have also tried actually doing a bit of transcribing, starting off with the recording and writing down what has been said, but it's very slow. So anyway, once you've got all that data, it's not actually complicated. It's just there's instructions. You just go through them and hope it works. And I'm sure it doesn't work the first time. Yeah, there's like 100 parameters, or it's probably not an exaggeration, that you tweak and keep on going. Yeah, well, I haven't done it because I can't. Okay, now onto the pronunciation model. In Sphinx, it's a dictionary. It looks like this. This is the American one. There were extracts of it. So it's showing up the top, bother and father are rhyming. So, and it sort of gets Canberra right. I think you say Gillard, don't you, for Julia? But that's the kind of thing where it's hard for the. There's probably people with both pronunciations, and so the way they deal with that is down the bottom. There's wind and wind. They just the second one they put in brackets, in parentheses, the 2 or 3, and they go on. For some reason, they can't just have the same entry twice. They have to put something else on it. And then by default, it only uses the first one. You have to do something tricky to make it work. So, and they squeeze it down to 39 phonemes. Now, what we need, what you need is 44 phonemes. And that would work for me too, but I could squeeze down to 42 by combining the bear and the comma and the kit. But there's no pronouncing dictionaries for us in a machine readable form. You can look things up on the paper. But there's a few British ones, and they're all for non-commercial use or you have to pay for them. And the guy, Robert from Canterbury, who tried making a model, he used the Select dictionary because he's at a university and you just get that for free. You don't notice that it's non-free when you're there. But you can't, even if you make the model, the dictionary needs to be there for the decoding as well as the production, so he'd need it at the other end. You can't use a non-free one and then throw it away. You need to keep it for the decoding. Now, text-to-speech systems, they read English, which is basically what the pronunciation model is. And so you can use them to make a dictionary by just giving them every single word and telling it to tell you how it's said. And they're using rules. eSpeak's a good one. What they did is they took some of those non-free ones, British English dictionaries, and they trained up their machine, or they went through and they made it so it pronounces every word or more or less properly from those. So it's kind of like money laundering. You take a non-free thing, turn it into a set of rules, and then you can spit out the other end a free version of exactly the same thing. And there are systems too where you just give them text, and they somehow, I don't actually know how the machine learning ones work, but they do. And so eSpeak, you can tell it not to speak. You can with a -q, and then tell it to spit out RPA, and then the IPA you can convert it onto the phonemes. Sphinx likes ASCII phonemes. The actual symbols you use don't matter so long as they're ASCII. And it does quite a good job of something like LCA. It says LCA 2013 rather than 2013. So you just sort of iteratively run through it, and then when things are broken, you fix the rules and go back. Now, for many languages, you actually don't need a pronunciation model because they spell things right. Okay, and then the language model, it just is estimates the probability of a sentence or an utterance. So, and it's like an n-gram. So it just it looks at the text it looks at 1 billion words, and it counts how many times each set of 4 words occurs, and then it just thinks that the ones that happen most often are most likely, which is a bit stupid, but they work. Well, there's kind of like 2 schools of thought on the language models. One is that they all suck, and the other one is that they're all good enough. And maybe they're both right. But. So maybe we would need to make a new language model, but maybe the American one would be good enough. I don't know. Yeah, so that'll do. The problem with the American language model is they spell things funny. Like we're in, theatre 1, well, the Americans wouldn't even spell theatre properly, or centre. And that's kind of embedded right in the language model. You can't just kind of change the spelling. I think it's you might have to remake the whole thing. So that'll do.